Question 6 is a very tricky object on an inclined slope. As you can see, I've already inputted most of the information. I'll just take you through it briefly now. The key point here is in bold it says it's at a horizontal force of magnitude T newtons, different from usual questions where the force acts parallel to the slope, but none the same. It's just a case of working out components. As you can see, I've put a horizontal and a vertical component in, creating a right angled triangle, alpha being the angle there, and we have T cos alpha acting parallel to the slope and T sin alpha acting perpendicular, essentially pulling the block into the slope. The weight of 0.8g is acting obviously straight downwards, with components acting perpendicular to the slope of 0.8g cos alpha, and parallel, pulling the object down the slope of 0.8g sin alpha. It's given that sin alpha is 3/5 or 0.6, and drawing a quick right angled triangle, we can see we have a Pythagorean triple of 3, 4, 5, giving cos alpha a value of 4/5 or 0.8. There's a coefficient of friction of 0.4, so in the first instance, if we resolve perpendicular to the slope, we can see that we have R is equal to T sin alpha plus 0.8g cos alpha. That's obviously the force in the string pulling the object into the slope and the weight itself. Also, we can then apply Newton's second law, parallel to the slope, taking it upwards as positive. Now obviously it's on the point of moving upwards. It's important to note because therefore we're going to have T cos alpha pulling up the slope minus F minus 0.8g sin alpha will be equal to mass times acceleration, which in this case is 0 because the acceleration is 0 at that moment. Our only unknown is T and F. Well, F we can work out because we know that F is equal to mu R, so that's equal to 0.4 T sin alpha plus 0.8g cos alpha. We're then in a situation where we can replace frictional force with an equation with T in it, hence having one equation with just T in. So if I substitute that in now, I get T cos alpha minus 0.4 T sin alpha plus 0.8g cos alpha minus 0.8g sin alpha is equal to 0. And if we just expand out, we have T cos alpha minus 0.4 T sin alpha minus 0.32 g cos alpha minus 0.8g sin alpha is equal to 0. Now this looks quite tricky, but actually what we've got now is we can say anything that doesn't have T in it, take over to the right hand side. So T cos alpha minus 0.4 T sin alpha is equal to 0.32g cos alpha plus 0.8g sin alpha. Factorize out T, so T brackets cos alpha minus 0.4 sin alpha is equal to the right hand side, and then dividing through we have T is equal to 0.3g cos alpha plus 0.8g sin alpha, all divided by that factorised bracket, cos alpha minus 0.4 sin alpha. I've deliberately kept out the values of cos alpha and sin alpha as being 0.8 and 0.6 respectively, but then you can substitute those in and you should find that T is 12.88 newtons.